Hi Daniel, hi Brandon. Can you both hear me clearly?
Hello, you can hear me okay?
I can hear you. Can you hear me?
Yes. I guess I'll mute
Yeah.
my mic.
Okay.
Daniel, I just wanted to check
Yeah.
a learning from the earlier session. Now, if Brandon
Yeah.
answers some questions, will you be repeating those or do you want him to leave some empty for you?
I mean, he can probably leave some empty, but Brandon is not so into Windows 10 than Walter was,
Right.
so I hope he will let me some empty.
Okay, okay, cool.
Yeah, I will probably only answer the ones that I'm certain about, or
Okay.
that I can easily just Google for.
All right.
Can you can't see my screen yet, right?
No, not yet. I am changing presenter to you.
Okay, okay, that was the. And how is my voice? Is it okay with the volume and stuff like that?
It's actually a little bit high, so could you do what you had done earlier? Could you maybe move the mic away a little bit?
Okay, so how about now?
Yes, this is perfect.
This is better. Okay.
Yeah. Okay, so now you're presenter, Daniel, but please don't share your screen just yet.
Okay.
Do you have the Q&A session that I sent you from this morning in case there's a delay with questions today?
I'm sorry, I was short away to close the door and disable my phone, so
Oh,
in
okay.
case you said something in the last 2 minutes.
Yes, actually, I was asking if you have that Q&A document from the earlier session ready in case there are any questions. I mean, in case there's a delay in the
Actually,
questions.
yeah, yeah, that's actually a good point. I didn't look into it, but I bring it up short.
Okay.
Uh,
Also, Daniel, I had sent you another email. A person has already sent us a couple of questions a few hours ago for this session, and he had asked if you could answer them. Did you receive that
okay.
email? If you want, I can just ping it to you again.
Yeah, maybe you can, because
Yeah,
I mean, I basically went to bed yesterday and now I came to the office. I didn't do.
I know, I know. There are three questions. I'm just pinging it to you right now. Just a sec. Yeah, I've just sent it to you. Brandon, I'm sending it to you just for your info.
Uh, Wow, there were so many questions. Walter was quite busy.
Yeah, he didn't even let about 10 seconds pass between each answer. It was quite cool.
Yeah. So outside here is a little bit construction. Can you hear that noise, or is it basically okay?
I don't hear any noise actually. Seems okay.
Okay, good. Um,
Okay, Daniel, 5 minutes to go. So please remember to share your screen and then press the start broadcast button before you start.
okay,
Okay.
thank you.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome to today's webinar about Windows 10 IoT Core. My name is Daniel Lang. I work for Toradex in Seattle. Before we start, a few stuff about the organization. So we will do the webinar, and at the end we will have a question and answer session. But you can actually put in your question while we do the webinar. There you should find a chat feature on your webinar panel, and if you have any question while the webinar is going on, you can just put it in there. We may already answer a few questions while the webinar, so my coworker may already answer some stuff. Otherwise, we will talk about them at the end of the webinar. So let's get started. So first I will do very brief talk about Toradex, then what is actually Windows 10 IoT Core, how does it compare with other operating systems. Then we will talk about the universal Windows platforms. We will have some demos. We will also very brief touch what's .NET Core, .NET Native, and how does the Azure IoT Cloud fits in all that stuff. So first short about Toradex. It was founded 2003 in Switzerland, and if you ask yourself what kind of accent I have, that's a Swiss accent. But I work now in the Seattle office, and we have offices around the world, and all these offices, they have local warehouse, local technical staff, so you can they can support you all over the world. What we do ARM-based computer module or system-on modules. You see there some of our modules on the pictures. These modules are used in a lot of different applications. This includes industrial, medical, automotive, but a lot of other applications too. So it doesn't go typically in consumer products, but otherwise, basically, it's a really wide range. We work with SoC providers, or system on a chip, from Freescale, and now they merged with NXP, with NVIDIA, and with Marvell at the moment. Then what's very special about Toradex, we provide also the software. So we have a really strong focus on the software. So these modules, they come with a production quality Linux or Windows Embedded Compact. And in case you find any issues or you need a change in the software, we can do that for free. So you don't need to work with a third party for the BSP, for the drivers. You can directly focus on your application. Then before we talk about Windows 10 IoT Core, let's short talk about Windows Embedded Compact. That's basically the operating system so far you would have chosen if you want to have a small ARM embedded device and you want to have a Windows-like API. So for the people who are not familiar with Windows Embedded Compact, or also called Windows CE, this is a very small footprint OS. We're talking between 10 to maximum, like say 100 megabyte memory footprint. It's real-time, so it's a real-time operating system. It supports the .NET Compact framework, and just so frameworks is roughly 3 or 4 kind of frameworks. It's the .NET Micro framework, where you can run on a microcontroller, which just need an operating system or an MMU. Then there is the .NET Compact framework, the one we use, which is a kind of a subset of the big framework, and then of course there is the big framework on .NET Core we'll talk later about. Windows CE also supports XAML, so that's for the user interface, the one you know from maybe Metro kind of app, Windows Store apps. But in contrast with desktop, this is used with native C++. So even if you have a Windows Store app, it's not so easy and normally to bring that to Windows Embedded Compact. It's highly modular, so I said at the beginning, I mean, actually you can do less than 10 megabytes, you can only do a few megabytes, up to 100 megabytes, and you really can customize everything in the system. There will be no new major version, so it's at version Windows Embedded Compact 2013, and there will be for quite a while support and patches, but there will be no Windows Embedded Compact 2016 or something like that. But Toradex is really still committed to support Windows Embedded Compact even on our upcoming modules. So the next new module will be NXP IMX7. We will release that at the Embedded World middle of February, and we will bring Windows CE to that too. And we still update a lot on the current version, so we still committed, and it's still very, very important for us, and we have new projects on that. A little bit downside on Windows CE, it's a limited ecosystem. So if you have a special driver you need or a very special library or tool, it's maybe a little bit hard to find that for Windows CE. And then for Toradex module, all Toradex module at the moment they come with a Windows CE license. So there is no license cost if you use the license that the module comes with. So that's also, it shows you how committed Toradex is to that. Then here a little bit about the history of Windows Embedded. You see now we have basically Windows 10, which is one core. All systems basically use the same kernel, but you saw in the history there was a Windows Embedded Standard, which is basically your desktop Windows, but for embedded, so it runs on x86, and for the embedded it can be a little bit more customized. And then on the really bottom you have Windows Embedded Compact. It has its own kernel, and that will stay, and that will be still supported as mentioned. There are some porting tools in case you choose to Windows 10, but basically Windows CE is still there. It's still optimum for small devices if you need real time, or if you already have Windows CE application, so that will be around. And then a little bit in the middle is Windows Embedded Handheld. This was originally very close to Windows CE, so same kernel, very similar. Most applications could have been moved to both, and then it uses they changed to use the kernel from the big window, but they still had another application model, and then they put the application model together, and now they try to make everything very uniform in this Windows 10. And then you have different versions of Windows 10, which we will see on the next slide. Here that shows you a little bit on the right side, you see a little bit roughly the three main embedded Windows version. So you have Windows 10 IoT for industrial devices. That's really what you know from your PC. It has a desktop shell. You can run Win32 applications. So basically, if you have legacy application, they will run there. And then you have Windows 10 IoT for mobile devices. That's about what you know from a Windows Phone or for a tablet. And these devices, they typically also have ARM chips, and they are many times in the form factor of kind of a phone or tablet or handheld scanner. So if you're in a store, you may see them, or in ski resort if they scan your badge, something like that. And then the one we talk about is a Windows 10 IoT Core, and here the form factor is really not decided. It can have a screen or it can't. It can be headless, it can be in all different form factor, and it supports a much smaller memory footprint, and you can get it for x86 and ARM. So it's the smallest version of this Windows. With display, without. Limitation is you can only run one graphics at the time. So the idea is that you have your own application, and that thing runs in full screen, and basically for the end customer it's maybe not even visible if it runs a Windows or a Linux or a QNX, so it's just that. But honestly, that's anyway most of the case for embedded devices. If you have to change, you can do it. You can run two apps, but it's up to you to design that. And then the other stuff is more like the real Windows. So you have updates via the Windows infrastructure. It supports secure boot. You have Visual Studio support, which I think it's a big thing, and always the latest and the newest. It's always up to date. It's simple to configure, so you still can configure a little bit. Of course, you can add your own drivers. You can change some settings and so, but it's much less and much simpler than for Windows CE. And it integrates very nicely in a Windows IT infrastructure. So it supports PowerShell, and for your IT staff, it maybe just looks like another Windows PC in there. So it's easy to set the settings for firewalls and so on. So the minimum hardware requirements, it needs an ARM v7, so let's say Cortex A9 or Cortex A15 and so on. So basically all newer ARM chips. 400 megahertz, 265 megabyte of RAM if you have it headless, 512 if you need the display, 2 gigabyte of flash memory, and in the future it will need like a trusted platform module, so that allows you basically to lock down and have a trusted boot, so you know nobody tampered with your stuff. I mean, at the moment that's not required, but in future and the firmware TPMs are possible to do, so that you directly use features of the SoC and don't need to have an external hardware. Then now the next couple of slides, I compare it with other operating systems. And I'm totally aware that this is a little subjective from my side, and also just picked a few points, and we probably can have a big discussion per slide, but I just should highlight some of the changes. And if you want to comment on that, please feel free to use the chat and we can discuss that at the end of the show. So the first slide compares it to Windows Embedded Compact, to Windows CE. So what's the advantage of Windows IoT Core? So you can have universal application. That means you can have one application and run it on a desktop, on a mobile phone, or on an embedded device, or actually even on an Xbox and so on. So that's definitely a really big advantage. You can tap into the Windows ecosystem, so all the Azure stuff works, but also the development environment, the libraries you can get, most of them work, and even, let's say, tools frameworks like the Unity gaming framework. We just tested that, and you can integrate that even with Windows IoT Core. We have to do some performance test, how well it does, but the tool and everything works. It just worked. You can download it and it works. So that's pretty cool. And the Windows IoT Core has standardized sets of components. So on Windows CE, you could take everything out of the operating system. The problem is if you have third party or other people try to provide software for Windows CE, it was very hard for them to know what they have to target, because every vendor had a little bit different components in the Windows CE, and with Windows IoT Core there is a clear API layer, a clear minimum standard of components, and you can program against that. What's disadvantage? Windows IoT Core is not real time. So if you have real time, that will not work as easy. But here, actually, Toradex provides a very nice solution. Many of our modules, or many, actually two, the Vibrate and the upcoming IMX7, they support heterogeneous multi-core. And we have other webinars on that, and on our developer website you find information. That means that the SoC has the application processor where we would run Windows or Linux, maybe even Linux without the real-time patch, so just your regular applications. And then you have a small microcontroller. In our case, that's a M4, Cortex M4, and there you can run your critical application, and you can do that bare metal or with a real-time operating system like FreeRTOS, ECOS, MQX. Something like that. So if you need more information, there is another webinar, contact us or check our developer website. The Windows IoT Core needs more hardware. We saw Windows CE can be a few megabytes. For Windows IoT Core, you should have 2 gigabytes of memory left. And then it's unproven. So Windows IoT Core is a really new It's not established in the market, so it's not fully clear where it will go and how successful it will be. Then compared to Windows IoT Enterprise, so that's the Windows Standard, the embedded standard before, or like the big Windows. So the big advantage of IoT Core, it's available for ARM. So we can't run the big Windows on ARM. IoT Core is also free, so there is a free tier, and there is also a pro tier which costs a little bit, and one of the main differences is how you have to update the system. And then another advantage is much lower hardware requirements. So it's a 2 gigabytes for IoT Core. I think it was 16 gigabytes on the slide for the big Windows. Disadvantages, you can't run desktop applications. So if you have a legacy desktop application, that will not run. So you would need to invest a little bit to bring that to a universal application. And that also has to do with the second point, backwards compatibility is limited. Also, if you have drivers, if they're only for x86, they may don't run on the system, and we will talk a little bit more about the APIs and stuff, so that there is some limitation. And if you have a legacy code, it may need a little bit of adjustments. There are also tools to help you with that. Then to Linux, of course, is the big Windows versus Linux discussion in general. But here a few advantages, I think, from IoT Core. The first point is simpler. That's mainly feedback from customers which were used to Windows and that they moved to Linux, and they were a little bit, let's say, overwhelmed about all the possibilities, about also the big fragmentation. So it's a little bit hard to make everything work out of the box. It's everything there, but you have to put it together. So with Windows IoT Core, the whole out of the box and until you're running should be simpler. Then you also have Visual Studio. Of course, they're a nice tool for Linux too, but if you like Visual Studio, you have that. And if you're already in the Windows Microsoft ecosystem, maybe with other devices, maybe with Windows PC in your company, that should be an advantage too. Then disadvantage, there's really not a lot of SoCs supported yet. We will talk about that a little bit more. And in general, the hardware support for IoT Core is much less than Linux. And it's less customizable. This can be a disadvantage too, especially if you need to go to very lower end hardware. Then what's currently available on SoCs and support? So you have the Raspberry Pi 2. So that's the about $35 one. So it's not the $5 one version. And then there's also the Dragon board. It uses a Qualcomm chip, which is actually even a 64-bit. But the Windows IoT Core at the moment is for ARM is a 32-bit version. So these are mainly maker boards. So if you're a hobbyist or so, I mean, they're definitely fun to play with. So what Toradex provide now, and if everything works well, we will have that on our web store next week on February 28th. You should see Windows 10 websites on our Toradex website popping up in the next couple of days. So we will provide a Windows 10 IoT as a technical preview on our Colibri T30. So that's a system on a module with NVIDIA Tegra 3, with a quad-core Cortex-A9. And the nice thing on this, so that's a module which already includes basically the whole system with RAM, flash, and all the interfaces. And you can use that for evaluation to test Windows 10. It comes with the Iris carrier board on your right, so you can plug it in. It comes with power supply and everything, so it's ideal for development, for testing. But then you can take exactly the same module and deploy it in high volume. So this module is already in volume production, so people already use that in products, and you can just take that and go into volume product. Typical, these high-end modules, they're used up to maybe about 50K a year. Our lower-end hybrid modules, they even go over 100K, but if you plan to have $500,000, a module is maybe not the right solution. But if you're in this really low volume to a few 10K, definitely have a look at that. It also comes with onboard eMMC, so that should provide much more reliability than a SD card. It supports DirectX, so Direct 3D is supported, so the graphics even at full HD look very good. That was a big disadvantage, for example, if people had tried it out on the Raspberry Pi, so you should get a very good graphics performance. And then it's really designed for ruggedized, so we have people using that in trucks and high vibration environments, and it's also long-term available, so we guarantee the lifetime for that module. Please keep in mind, if that gets available, that this is a beta preview. So there's still, I mean, there's some stuff working. So HDMI is working, or DVI, so you can connect the screen. You have USB, you have Ethernet, you have I2C, you have SPI, GPIO support. So you can do a lot, but there's still some stuff not working. For example, LCD is at the moment just a fixed resolution, so you can't change that. And there is, of course, a lot of performance improvements still needed. And we just want to see what people like to do with it. And so if you have a program, or if you're a little bit really already have a timeline, do not hesitate to get in contact with us. If you get the kit and you find an issue or think stuff should work different for your use case, just get back to you, and we will talk about that and see if we can find a solution for you. So very excited about that. It should also be able to download the Windows 10 next week if you already have a Colibri T30. So there will be more details coming up on our website in the next days. Let's talk about a few examples. So we were already, since a few months, we engaged with a few customers and checked their use cases, and most of them work on a proof of concept. And here I just picked a few. So one was a factory automation customer, and he has a high-end line with an x86 PC they use in there, and they have a low-end one where they use ARM, like a small ARM with Windows Embedded Compact. The problem is the big Windows and Windows CE, they're similar in some part, but it's not so easy to move application between, so they had to do quite some engineering to keep these two product lines in sync. With Windows IoT Core, they could run exactly the same application on both devices, so that would simplify the process quite a bit. So the second one is a gateway, but the gateway allows the real end customer to run their own application on it and do a lot of customization. So the end customer, they have a lot of experience with .NET and Visual Studio. And before the customer building these network gateways, they were using PCs, and then now they moved to ARM, and they basically provide that currently with a Linux and Mono. But they got feedback from their end customer that they really would prefer to stay on Visual Studio and just keep the development. So they hope with Windows IoT Core they still can use ARM, but they can provide the whole Visual Studio experience, the whole .NET experience to that device. And this is actually a headless device, so they would not require a screen here. And then the last one, a little bit different. So that's equipment for lab to do tests in a laboratory. And so far they had a small device with an ARM in it, also running a Windows CE, and it was not connected to the cloud, but it was connected to another PC, and then on the PC they provided a PC software which could do additional analysis, so which need very heavy CPU and also archive function, and so on. And now they would like, actually, instead of providing a PC solution, they would like to provide that additional analysis and archive function as a service in the cloud. So like Windows 365, you can have now in the cloud, and it's pretty popular to provide software as a service. So they would like to do that. And they have planned for that, but for that they have to connect the device to the cloud. And Windows IoT Core really integrates nicely with Azure, but it also is much easier for their PC stuff of these lab companies, because it just comes up as another PC. So all the rules and everything, if they have to configure something, it's easier for them. So let's talk about this universal Windows platform, which is really one big selling point of Windows IoT Core. That means you can develop one application and then deploy it on all these different devices, like from small devices to mobile devices like tablet, cell phones, to PCs, even Xbox or the Surface Hub, which is this huge screen from Microsoft you can use for presentation and collaboration. And there, I mean, the tools provide features, so even different screens you can accord for that, different resolutions, different DPIs. So it's very nice. And that also works for drivers. So there's also a universal driver model, so you can write one driver and run it everywhere. So for this universal application, you have a choice of a lot of different programming languages. You see them here. Then for the graphics, you can use XAML, DirectX, or HTML. It integrates with Blend. That's also a tool to do the user interface you may already familiar with. It's very nicely integrated with cloud services. So if you have anything in Azure or so, there is an SDK, which I will talk a little bit about it. And there are a lot of samples from Microsoft on GitHub. So let's go to our first demo where we will show how you can run a universal application. So give me a second to get that ready. So I'm here on GitHub. You see us, there is a universal samples, and we can browse it here, and you see there is really a lot of different samples available. And yeah, there are tons of different things. Most of them work on Windows IoT Core. We didn't try all of them. Some don't, if they need special component. We will go here with the basic face tracking. And then if you go in there, you see there is for C++, C#, Visual Basic, you see some general description. You see how to launch the sample. And we actually already downloaded it here. So you see here the code. You see here we downloaded it. It's still the basic face tracking. And first we'll try it on my local machine. So I just downloaded it, basically didn't do any changes, and launch it on my local PC. So it's X8, it's 64-bit machine. So just choose that, press launch, and you should see the application coming up. So here we can start streaming. So let's see if we can set the breakpoint and if all the Visual Studio stuff works. So that's in the current frame where we access the current frame, and like to the face detection, you see tooltip works, breakpoint works. So everything you used to. So for the second test, let's run it on an ARM. And my ARM device here will be a phone, a Windows 10 phone. So the only thing I had basically to choose is choosing ARM and change to the phone, and I choose device. That means the device is connected over USB. So I have a Windows 10 phone connected via the USB cable, and actually I have a webcam here. And you can see the Windows 10 phone here. And of course, the frame rate is a little bit low from the transmission here in the webinar, but you should be able to see it. Launch the app. Now we have the same app adjusted for the other screen size. So I can start streaming. So you could you saw that, and same here. Just short test the breakpoint. It also breaks. Still works. So very simple to go from a PC application to a phone application, and now actually go to the Windows IoT core device. So here we choose a remote machine, and now for that we have to do small changes in the settings. So go to properties, and then you have to choose actually the IP address, and you have to say it's a universal application, that basically no authentication or not encrypted. And then start it, and it will build it, and it will download it. And also about before the IP, you could also choose the name of the device instead. So let's show you a short what kind of hardware we actually use. So I show you here, this is our evaluation board with the Colibri T30, and we connect the monitor over DVI. And on our evaluation board, we have these nice jumper areas where you have access basically to all GPIOs. If you buy the kit, you will get that. That's what the Windows 10 IoT kit will be, the Colibri and the Iris board. That's the splash screen from Windows IoT Core. It's not customized for Toradex at the moment. It's just the default one. In the version, I assume we will brand it a little bit. Toradex, maybe I add a few Toradex specific feature, but that's basically what you get when you boot up Windows 10. So now we start the application. You can see it looks basically the same than on Windows PC. Start streaming. So also here, set the breakpoint. Actually, the camera was connected over a USB here. So breakpoint still works. Run it. So that was now basically, you could see we could run an application we've just found on GitHub, and we could bring that very easy to all these different devices. So then about if you want to migrate, so you have maybe a Windows application which was not written for universal application, but going forward, I mean, it has a lot of advantages here, a little bit how you have to move if you have GDI, MFC, Windows Form, or VPF for your user interface. We recommend to use XAML, DirectX, or HTML. If you have Win32 native or native code, there is still a subset of the Win32 APIs available. .NET library, we have now the .NET Core. We'll talk about that later. And then also maybe short about the drivers. So even you have driver available, you can move them forward easily. And we will talk a little bit which driver are easily. So Microsoft scanned about, they say 100,000 drivers and see what kind of API and DDI use. So DDI is a device driver interface, and they defined that. And the DDI is the same for all different Windows versions, IoT Core or the big Windows. That's all the same, but the API is different between the different Windows versions. And there is a lot of sample drivers on GitHub too. There's a lot of open source. So about drivers, so for Inbox driver, Inbox means they come just from Microsoft and they're part of the operating system. They just work. So you see, for a mouse, a keyboard, a USB touch, or even the cameras we used, we didn't have to do anything. It just worked out of the box. Then if you have kernel mode driver, they should be like kernel mode driver from big Windows or kernel mode drivers from Windows 8. They should work most of the time. most of them rebuilt for ARM, but they should work, or you have to do small changes, so there should be not too much effort. If you have user mode drivers which access the API, then you may have to rewrite them a little bit. And that's also when we ported drivers to our Colibri T30. That was also a little bit what we had to do. But there are actually tools which shows you which APIs are not supported. Sometimes even recommends other ones. So it's definitely possible to do that. I recommend, if you do a driver, develop it for Windows IoT Core, and then it will run everywhere. So that's more, maybe that's not typically something actually our customer do, but if you're a peripheral company and you design your new, I don't know, Wi-Fi module or something like that, do it for Windows IoT Core, then it's very easy to get it running on other systems too. Then talk short about the Windows IoT low-level access. So actually, in general, Windows IoT Core is kind of a subset of the big Windows, but for that low-level stuff, it actually added some things they were not available so far on big Windows. So to access the GPI or I2C or SPI, it's not something you normally easily do on your PC, or you have PCI Express extension cards and so on. So that's not possible. It's available via a Windows device namespace in the Windows IoT Extension SDK. So for that, I also have a demo pre-recorded. So let's bring that up. So that's a Blinky application. So very simple blinking. So also start that here on our remote machine, and I have that here from GitHub. It's another repository. This is more for really IoT Core, so there's a lot of the demos Microsoft showed. You see a lot of low-level access motors, building your robots, and so on. So they have a very, very simple Blinky, and that's the one we choose here. So the only thing I had to change is basically there's a LED pin equals 2, so I had to change that to a pin number which fits for us. So originally, I don't think that was 2. So built that here, and download. I have all the debug stuff activated, so it takes a while. So here you see actually how to initialize the GPIO controller, so you can get a handle for the controller, and so pretty straightforward. And here you see actually the SDK extension, so to get access to that. Then you see here how to open the pin, how to set the value, how to define if it's output or input. And this kind of syntax, if you use Arduino or if you even use Windows CE with Toradex libraries, that should look a little bit familiar. So it's very easy and straightforward. If you go down here, we have the Blinky implemented. So, I mean, you set it low and high and change, and that's a timer. It's called every 500 milliseconds, and either set it low and high. I mean, this is a super easy, super simple code, and it's also not actually the fastest way to access GPIO. There is a faster way, but just here to show you how easy that is. So we also have here an external camera. You see there the LED. Here I connected it with a GPIO on our evaluation board, so that's very easy. So let's try to get the code and the picture on one screen, so you can actually see what happens. So you see now I step through and I write to the LED, and you see it's off. And then the other time I write high in it, and LED is on again. So very, very straightforward, and you see debugger still works. So if I take out the breakpoints, you see it blinks. So very, very, very similar, simple. But then here also that's we also have UI, which shows a blinking pointer. It's a little bit hard to see. So very, very simple. Okay, let's get back to the presentation. So let's short talk about .NET Core. So far on the Windows PC you had the .NET, the big framework. It's like a big package installed on your target machine. You had to target the right version, and it was this big, more or less monolithic block. So with .NET Core, it's now basically componizable. So your application, you basically just pick the stuff from .NET you need, and this is also actually open source. So Microsoft is a lot of the .NET stuff of this .NET Core thing is open sourcing. When it started, it was a subset of the big .NET framework. But I heard that it probably progresses faster. So in the future, you may have features in the .NET Core you don't have on the big Windows. So if you use a universal application, you would target that. And there is also, if you do server ASP stuff, there is also kind of a version Microsoft uses for that. The nice thing is because now it's componizable, it's possible to do .NET native. So you don't need to build the whole .NET. So you really can pick the features you want and then build it to native. And what Microsoft expect here is that you have the convenience of .NET and the feature set of .NET. So if you use .NET, it's pretty productive to develop stuff. Disadvantage, it takes a while to load and so on. And now they do ahead of time compilation directly to native code. So you should get both. So here are a few performance data. We didn't verify that. That's from Microsoft. They say 60% faster cold boot and 15 to 20% less memory. And then there's also some special use cases where you get quite some performance improvements if you do native. It depends very on your app. And you could also, because you only use the parts of the .NET framework you use, you could actually pack everything together in one application. Then you don't depend that much anymore what kind of version of .NET it's installed on your target. Then, I mean, it says Windows IoT Core, so we didn't really talk about IoT too much. Of course, even if it says Windows IoT Core, you can use that for whatever you used so far. So it's just another operating system with some cool features. But of course, nowadays, a lot of devices need to be connected with the cloud and have some remote access capabilities or provide data, or as we saw, software as a service. And there's a lot of business around this IoT. And there is actually a little bit a separate thing from Microsoft. It's called Azure Certified for IoT, and that's not limited to Windows IoT Core. And Toradex, it's actually a member. So we have certified several of our modules with several of our operating systems to work together with Azure. So and that includes Linux, Windows Embedded Contact, and Windows 10 IoT Core. We tested C, C#, JavaScript, Java, and here more or less all our newer modules are verified. So if you would like to learn more about the whole Azure, I recommend you to visit us at Embedded World. If you make it to Germany, middle of February, we will have a nice IoT demo, really like connected devices. You will also see Windows 10 IoT Core running. And then there is also a webinar from Walter. He will do it in April and really talk more about the IoT aspects and about the cloud and how we can support it. And that works. It's very nicely integrated with Windows IoT Core, but it also works with Linux or Windows CE. And then if you have more information or want to know what exactly was tested, you can go to developer.toradex.com. that's also the place where you will see in the next couple of days popping up articles about getting started, IoT Core, and so on. And in general, if you have any question about Toradex products, have a look at there. It's like more than 800 articles, and we update that daily, most of the time more than once even. So very up-to-date information. So with that, we reached our Q&A. So I will try to answer some questions. I will have to look at them. If your question is not answered or some questions pop up later, do not hesitate me to contact on my email, or you can call the Seattle office, or you can try to connect any of the local offices. We also have the developer page already mentioned. Then we have a community. So if you go to toradex.com/community, there's a new forum where we help people. And there is some URLs from Microsoft about Azure and about the IoT Core. So give me a second, so I will look into the questions here. Okay, so there is first some questions about the webinar itself. So it will be available as a download with voice and with all the demos we did and everything. We will get that online after the meeting. So see here, my coworker already answered a couple. Okay, so there is a questions about porting tools. So that there are a few tools. So depending what you do, so one thing you can do is just try to the application you already have and try to build it as a universal app in Visual Studio. And then you probably already get some information which helps you porting. And then there is also a tool called API Verifier, where it basically scans your application and tells you which API calls are not available anymore. And then there is, I think, even some recommendation what you can use, or you can go online. And these tools, so far, they're from Microsoft. So we, at Toradex itself, we didn't do any porting tools so far, but certainly we can help you if you run into issue. And I mean, we also got a little bit experience. Okay. Okay, so how easy can a Silverlight application based on Windows CE be ported to Windows 10 IoT Core? This should be actually straightforward, but it doesn't run out of the box, so that's sure. But Silverlight, it's basically XAML, and that's still what's used. So it should be as straightforward, but you definitely have to rebuild it. You probably have to build a new project, and also the binding between Silverlight and your business logic will be a little bit different. So there's some effort involved, but it should be possible. Okay, so it's a question about the partner program. This is a little bit out of topic, but maybe interesting. So we have, if you're a software provider or a hardware provider, we have a partner program. So if you're a software or you have services, for example, you provide a special software packages or customizations for our customer, we have a partner program. So just write to our local office and we will enable that. Also, if you have a carrier board already designed for Toradex, you can be part and we can feature your carrier board on our website. Does IoT support SGUI for apps running in it? Yes, of course. So even DirectX, so even hardware accelerated, and you can do a full HD screen. I mean, you can do games if you want, or digital signage. So definitely, but it limits it to one user interface. And actually, we not really talked about that, but there is for other GUIs or for remote stuff, there is a remote user interface, and I can bring that up here. So this is connected to Windows IoT Core here, and that comes out of the box. And you can see here, you can see processes and a lot of features you normally would run on a GUI on the device. We run that here on a web browser. And can access. So that's kind of workaround with the limitation you only can have one application. So you run your main application, and all the maintenancing here is basically done on the side. Here you see the device tree and so on. And that's really the headless or the remote UI. That's a big use case for it. There is a question about Threshold 2. Yes, the version we will release next week will be based on the Threshold 2. Okay, we can put the links we have here in the chat window. I hope some of my coworkers can put that in, so you can click on it. So another question about the real-time compatibility. So it's really the Windows 10 IoT Core and Windows CE, they have two different kernels. So that's totally different. But the API is kind of similar. So if you have a Windows CE app, it's maybe possible to move that. Of course, if your Windows CE app relies on real-time timing, that will be not possible. So if you control a robot and you need some very critical timings for your motor controls, and if it doesn't is in these timings, you will hurt somebody. I mean, that's definitely not the right way. Then I recommend to use a heterogeneous system or stay within Windows CE. But if you don't rely on that, you can do that. And actually, I showed a way how to access the GPIOs. There's actually other ways, so you can access the GPIOs pretty fast. So it's pretty fast, it's just not real time. Yeah, so there is a question again about porting from Windows CE to IoT Core and about the Toradex libraries. So for Windows CE, we provide these nice libraries how to access the hardware. So at the moment in the version we will not have this library in. We actually looking at that because there is a way to have direct memory access, which would allow us to port the library quite easily. So we could do that, but on the other side, if you use this Windows CE libraries from Toradex, you will be not so compatible with the other Windows IoT systems around, and that's maybe a disadvantage. So if you have a use case, please write us exactly this question and we will look into it. Really porting tools. Maybe we will do a follow-up webinar. Maybe we really can dig into the porting. That seems to be a big topic. Yeah, so there's a question, does Windows IoT Core support some basic stuff like desktop, file explorer, notepad, and so on? And the simple answer would be no. But for most of that, it's a workaround. For example, I just showed you one, the remote thing. So for example, you want to have the performance monitor or task manager. You get that basically now over a web interface. It's a file explorer. There is no local one, but you can SSH in, or you can use PowerShell, and you use the command line to browse it. Or there is also an FTP server running, so you can just connect with your PC via a web server or SMB. So you can mount the Windows IoT Core as a network share, and then you can access it and you can copy your files around. That's what we do a lot. We also, just for testing, we may also provide the Windows IoT Core, so you can launch it from a USB stick, and then you can modify stuff on a USB stick, basically offline on your PC. That's also sometimes we use that. Again, about real time, it's just we cannot guarantee a timing. I mean, it's normally in time, and I mean, of course, if you have Ethernet, you will not lose packages or stuff like that. I mean, that works, but we can basically not guarantee you something, and maybe really in worst case you lose an Ethernet package. That's with Ethernet not a problem, but if you have a machine and you have to stop always in a half a millisecond, and if you don't do that, something goes bad, don't use directly Windows 10. I, in this case, really have a look at the heterogeneous multi-core system. So it's anyway, if you do real time, if you have a small operating system and basically a simpler application, it will be much easier to guarantee all the use cases for it. So look at our new IMX 7 and the Vibrid. Of course, at the moment we don't support Windows 10 on that. On the Vibrid, we have 2 less memory, so I don't think we will ever do that. But for the IMX 7, we may consider that. So if you think Windows 10 and IMX 7 would make a good combination for your use case, let us know. What version of Visual Studio is required? You can actually use the community version. So use the latest one, and there is a free version, and that should work. Yeah, great. Let's start with the kit. Yeah, I really hope I mean, there's still a few things you have to polish up, but if everything is good, we will have the kit online next week, end of next week. Will IoT be available for IMX6? So that's still an open question. We definitely look into that, and yeah, we have some efforts in that, but it also depends on other people, not only on Toradex. So please write us an email if you're interested in IMX6, and we can get you up to date, or maybe already do something. Oh yeah, so is it possible to store more applications at a device which will be called by each other? Yes, that's possible. So you can launch other applications, and you can also communicate with each other. So there is services you can run. So even if you have only one application which has a GUI, you can have a lot of different applications and then have one application to show that UI, or you can switch back and forth between applications. So that's definitely possible. Okay, can I evaluate a board from Toradex? Where can I buy one, and how can I configure it? So you can buy it on our web store. So we have a web store, and if you wait until end of next week, there should be a special kit which already have Windows 10 IoT Core pre-installed. If you can't wait and already want to get the hardware without Windows IoT Core, you have to order a Colibri T30 with NVIDIA Tegra 3, and then it will be available. So how long will it take until Windows IoT becomes proven? Of course, that depends on the market and how much interest it is. Yeah, so that's hard to answer. Also, it's depend on your business. I mean, some medical or some people are in industrial application. they literally hesitate and they want to see that stuff is in the market for many years because they're adopted, and then other people, they always want to have the latest and take maybe a little bit risk, but have something new. So that's really depend on the company and industry and so on. If we do any comms in future with Qualcomm as Snapdragons, there is nothing in the roadmap. However, we always talk with Qualcomm and other SoC providers and see what's the latest. So if there is something new, exciting, which fits in our roadmap, that would be possible. Today, no. What will be the price of the kit? So I think we will send you a link to the follow-up. It will be quite a bit discounted. So if you can wait for the kit, you will get a discount than if you buy the T30 and the Iris together. Support for Wi-Fi, Bluetooth devices. Yeah, there is support. So there is some Wi-Fi USB dongles you can directly connect. So we tested that. There is also Bluetooth, which should work. With the Bluetooth, I didn't test. The Wi-Fi works quite well. It's a little bit limited what kind of chipsets, but that's possible. Just write this. Is it possible to use Windows 10 Mobile on the devices? So, as an engineer, from a technical point of view, I would say yes. It's possible because, I mean, the low level is very similar. I mean, memory, everything we have enough. Honestly, I don't know about the licensing and what you need to get access. There is also, as far as I understand, some limitation on the form factor, so it depends on the device and what you like to do. But if you have a special use case, just write why you think you want to use the mobile. Maybe there is a workaround, or maybe it's possible to have the mobile license. Again, real time, will it handle 100 milliseconds? Yes, that should be possible in 99.999%. Okay, so okay, there is a Mew coming. If it will work on the T20, no, it will not work on the T20 because it needs ARME7. It also needs some floating point units, and it's a little bit different on the T20 and the T30. And we at the moment we don't have planned to support that. It's probably also not possible. There was some question about the Apalis T30. This one actually works basically. We tested that. It's not officially supported, but Apalis T30 you can boot and USB works. The problem is in the current image we don't have PCI Express support. So it means the PCI Express on Apalis wouldn't work, and also the Ethernet on Apalis is connected via PCI Express, so you will also not have Ethernet. So there are USB to Ethernet adapters you can use if you want to use an Apalis. But I recommend you to get started check out the Colibri T30. Okay, I think we are through 1 hour. Also, the questions slowed down a little bit, so we will keep that online for a while. So if you have some questions, put that in. But for everybody else, thanks a lot for joining our webinar. We will follow up with an email with a link where you can download the webinar and with a link where you can get the kit. And if you have any questions, do not hesitate to contact any of the channels we present. Thanks a lot and have a good day.